Hello and welcome to week 4. So once again, I just want to let you know that because we have a quiz coming up, there will be a password that's given somewhere in this video. So please stay tuned and listen for that. A reminder that workflow is top to bottom, and be sure that you're taking those good notes. Keeping really nice and organized. Week 4 due dates: discussion board Wednesday, homework Sunday, and quizzes are due Monday, excuse me. And there's again a multiple choice and a calculate portion, and then there's a free response portion. So you should be able to go see feedback on the free response portion for the weeks 1 and 2 quiz, quiz number 1. Go to your gradebook and click on the assignment, and you should be able to open up and view your responses, and you should see my comments there. If you got a 15 out of 15, I usually don't leave comments, but if you didn't earn full points, then I'll definitely explain why in there. This week we'll be dealing with, excuse me, I have this backwards. So this week is what's in a linear model, and I'll go ahead and wrap up the rate of change discussion board. So this time you'll be thinking a little about linear models and applications of linear models. And this week we'll be focusing on linear regression and introduction to exponential functions. So linear regression, I'll have a video on how to do that. The videos that you'll be seeing, some of them that were recorded at the time were used a TID3, but I'll post a video on how to do it in Desmos because I think it's far more intuitive and far easier. And remember, on the exam you have access to Desmos, so on the computer in the Learning Center. So learn how to do it in Desmos. It's much easier unless you really like using the TID3. This week we'll introduce exponential functions, and just now is a good time to give you the password for the quizzes for this week. The quiz password is linear, all lowercase letters, linear. So just like this word here, linear, but with a lowercase l. That's the password for the quizzes this week. I'll go ahead and wrap up the discussion board next, the rate of change idea. So I think most people hit this pretty spot on. 40, sometimes we say 40 mpg, but the better way to write it is 40 miles over 1 gallon. That's what 40 miles per, that's what miles per gallon means. It means how many miles do you get for 1 gallon of gas. So if you want to drive 40 more miles, you will need 1 more gallon of gas. That is a rate of change because it does indicate how much more, how many more miles you're able to drive on 1 more a gallon of gas. If we switch this rate of change, we get 1 gallon over 40 miles. So that's the remember, it's always change in output over change in input. That's just by virtue of definition. So if we have gallons be the output and miles be the input, well, think about that. If in a function, if I input miles, I could figure out how many gallons of gas I'm going to need to use. Whereas here, if I had a function for this, so I input the number of gallons, it'll tell me how many miles I can drive. So sometimes we want to know, how much gas will I need. If I know I get 1 gallon, it requires 1 gallon for 40 additional miles. Now, if I want to have this be a unit rate, that means I want the denominator to be per 1 mile. Okay, well, if this is 1 gallon to 40 miles, I really only want to look at this rate for 1/40th of that, right? Because if I multiply anything by its reciprocal meaning 40 over 1, its reciprocal is 1 over 40. Alternatively, if I break 40 miles into 40 individual pieces, I will get 1 mile. Well, if I do that, if I only drive 1/40th of the total distance, then I need 1/40th of the amount of gas. This process always works, even if these values are funky. If this were 1 gallon to 22.5 miles, then I would want to drive 1/22.5th of it. It seems strange to say that, but this doesn't have to be a whole number to apply this rationale. So if I want only to drive only 1/40th of that distance, which is 1 mile, then I'll only need 1/40th of the amount of gas, which is 1/40th of 1 is 1/40th. Well, 1/40th, or 1 divided by 40, is the number 0.025. So now I can interpret this. So if I want to drive, or you will need to use 0.025 more gallons for every additional mile you want to drive. Or I could say for each additional mile I want to drive, I will need 0.025 more gallons of gas. This is convenient if, let's say, you want to determine how much gas you'll need, as I mentioned earlier. So if you want to drive 300 miles, and you know it's 0.025 gallons for every 1 mile, so for 300 miles, it'll be 300 times that. Or if I want to do a dimensional analysis here, my miles cancel out, and I'm left in gallons, so I would need 7.5 gallons of gas to make that trip. assuming, again, that on average I get 40 miles to each gallon. So that's it. So hopefully this has helped out, and hopefully this makes sense, and hope you have a great week. I look forward to seeing you in the next discussion board, and keep up the good work.